All right, folks, welcome to the last class for the SQL. Today, you're going to be learning SQL join and union. A couple of things I will cover is SQL join, union. You're probably curious about creating a ticket, creating a table, how to add table. We did not do those yet, so we will cover that. We'll talk about what DDL, DML, DCL, and TCL is, kind of wrap things up for you on SQL. Also, today is not the end of SQL. You're going to see this come back up. When we get to the Selenium course after Java, we're going to install the real actual SQL database software, which is MySQL in your platform. And we will do some automation where we're going to be calling data from the SQL server into your automated test cases. So this is just giving you the foundation. And when we get to automation, you're going to do hands-on real world scenarios. Um, and we'll be using database for data validation in our automated test cases. Give me 1 second, please. Sorry about that. Had a technical issue. All right, and then we'll talk about the homework that's due, kind of the same thing that you've been doing, no difference. So we'll finish off with that. Now, today's class, what we're going to do is we're going to put together more than one table. That means we need data from not just one table. So far, we've been talking about getting data out of one table. We're deleting data in one. We're adding data in one. But today's class is going to be focused on multiple tables. And imagine this scenario right here. You got a table here. This is the orders table. And then you got another table that's customers table. Now, if for some reason you wanted data to display in a separate table for your website, for example, you have a website and in your website, you need to display data, but this data has to come some from this left table here, which is order table, and then some data needs to come from the customers table. What are you going to do? Imagine you need to display something like this, which is order ID, customer name, and order date. Notice this order ID is coming from this orders table. Customer name is coming from the customers table, and order date is coming from this orders table. And you need to display this in a web page that you provide to your customers. How are you going to do that? Well, we can't do a select query or a single select query. You have to go tap into two different tables and you need to mix those queries together. So there are several ways to do this. The most common way is called join, and we're going to be joining two tables to output this. Couple of things you need to look at. is which you need to focus on which columns and where these columns are coming from. So that would be your first task on this, is to identify which table you need. The other thing that's important here is you have to match these two tables based on a common data, okay, a common column of data. Who can tell me which column in both of these tables are common?
Customer ID.
Customer ID. So if you don't have a column that does not have the same data, you won't be able to join them. So that is a prerequisite for you to do that. Notice here on the left table orders and the right table customers, they both have this customer ID column. And on the left table, we got this customer ID 2, which matches with a customer ID 2 on the customers table here in this name. And we got that displayed right here. So with your join command in SQL, SQL is going to go inside and try to first match to see if there's any matching. And then it's going to display that record that's matching right there. For example, 37 here, 77, they have been matching with this customer's table and they got displayed down here subsequently. So that is basically the fundamental of how we join. Now, there's several types of SQL join that um, that you're going to learn today. Uh, Four of them are the most common ones, so I'll just cover those. But before we do that, remember there's two things. One is the combined row of two or more. SQL combines two or more rows of data from tables, and you have to have a related column. So if there is no related column between those two tables, it's not going to work. Now, the first type of join that we will look into is called an inner join. Hmm. Inner join is where you have um, you have two tables, and obviously has to have a common column that both tables have, so that you can join them together. But if you use this keyword inner join, all you're going to display is only the matching ones, only the matching related column IDs data in the output. You're going to leave out the unmatched ones. So let me get my pen tool here. So these unmatched ones are not going to get displayed. These are not going to get displayed, but anything matching between those two on that related column is going to get displayed when you deploy that query. So we got this inner join is returns records that have matching values in both tables. Okay. On the next one is a left join. Similar idea. In the left join, you have two tables and you have a matching column for them, which is here. If you invoke the left join command, you are not only going to get all the matching data that two tables have between them, but you're also saying, hey, just go ahead and give me everything else from the left side as well, but on the right table or the second table, don't give me unmatching data. Okay. It's just the way you want, it just gives you that control of choosing how you want to display that data. Basically, that's it. So in definition, left join returns all records from the left table and the matched records from the right table. Well, you can probably guess what's going to be the next one, which is the right join, which is just the opposite of the left join. This time you want this right side table data, all of them, including the ones that match with the left side ones. But anything that does not match on the left side ones, you want to leave those out and then display the output. So that will be your right join, just the opposite of the left join. Sometimes they use this outer word. We're not going to be using this outer word. So right join returns all records from the right table and the matching records from the left table. And then one last one is your, it's called the full outer join. And in full outer join, you got everything, not just the matching records between the two, but also you are displaying everything that doesn't match on the left table and everything that doesn't match on the right table as well at the same time. So in definition, full outer join or full join returns all records when there is a match in either left or right table. You include basically everything. Any questions about these 4 types of joins that we're about to do right now as an example?
So one question, right? Says
Personally.
you're telling the left and right. Is it so? Definitely, there we need to define which will be left, which will be right table. Right?
Absolutely. That's correct. And the definition of left and right depends on which table you start with. Because we write from left side to the right side, when you start your query, whichever table you name first will be the left table. And then whichever table you name second will be the right side table. Okay, so we'll see an example right now to see if this clears up a little bit more. So let's look at the first one that we're going to experiment with, which is inner join. In inner join, we're only going to find matching records from 2 tables. So in this example, really, it doesn't matter because you're not really including everything. What I mean is you are just finding matching value here. So either you specify the first table first or second table first. Either way, it's only going to give you the matching values between them. But you will see when we get to the left join or the right join, it really matters which table you name first, because whichever you name first, it's going to be that left one. And if you want to flip that over, then you would have to name table 2 first and table 1 second, and that will become the other version of that. By the way, you can probably guess that left join and right join, since they're opposite, you don't ever have to use the right join, for example. You can always use the left join. In every cases, if you want this become a right join, all you do is you switch the tables from left to right, or how you write the query. It will clear up in just a second. So select records with matching values in both tables is what inner join is going to give you. This is the syntax for it. Please ignore this part right here for now. The PowerPoint animation just pulled that forward before I wanted it to come in. But take a look at the syntax here. You got the select statement as usual, nothing new. You got the from that we did, and then we named the table, nothing new. The only new is now you're saying this word inner join and you're naming another table there. So there's your table 1 and there's your table 2, and you have to have a matching column like we talked about, and you have to specify which matching column it's going to do it on, and therefore we have this keyword called on. All right. The only other change, remember that right after we write the word select, only thing we write here is the name of the columns to display. You can have one column, you can have more than one, you can display all the columns. Now here's one thing you have to be different when you do inner joins or joins. You cannot name the columns the way we used to anymore. Because we have two tables, you have to name the table first, okay, and then put a dot and then name the column like that. So these are the only differences that you're going to see. Again, the table names, the column names have to have the table in front of it with a dot. So table name dot the column name, like customers dot customer ID. It's going to be like that from now on for the join only. And for inner join, this is where your second, right after this command, you put your second table name. And this will always stay the same, where you say on, where you found the matching two columns. And those column names also have to be named with the table name first, like the table 1, this column, and then table 2, this column, that they are the matching ones or related ones that we're trying to match on. Let's take a look at an example, real world example here, and to see if we can clear this up. So here's this question. Display order ID. So let me highlight some of these things. You got this order ID. That's our column. Customer name. That's our column. For matching order ID, see this matching order IDs? This is the matching field. And here are the tables from customers and order table. So let's go visit those. We know that these are columns. Here's a column, there's a column, and this is the matching. So um, if I were to just kind of point it out to you that this order ID is going to go right here. You can kind of guess this customers is going to go right here. First table. Orders table is going to go second table. And because the question is asking you to display these two columns, then these column names are going to go right after select. And this column name is going to go right after select. So if you put this information in this frame, you got your answer. So let's take a look at this. I'm going to bring this piece out right here. And just to kind of eyeball things, you don't really need to look at the table, but let's say we're going to. The question is asking you to display customer name. So we're going to be taking customer name from here. which is this column. And the question is asking you to take order ID from orders table, which is going to be this, this column here. Those two columns is all we're going to display. Now, between them, the question already told you that both of those tables have matching um, uh, matching column. Actually, I made a mistake. The question did not specify this correctly. By the way, see, it says for matching order IDs. Matching order IDs, this information just tell us that we're just looking for matching ones from both of these, but it doesn't really say if these are the matching ones, or if these are the related fields or not. So let's investigate these two tables just a little bit more. We know we have this customer ID here. So this customer ID could be a matching field for customers. There is this order ID. We can also check to see if order ID is existent in this customer's tables or not. We have to make a determination there first. So let me open up customers. And the only unique ID and matching one with customers and order ID is this customer ID. That's the only thing I see. Therefore, that is going to be our joining condition or the relational or the matching columns that we're looking for, not the order IDs. But the inner join, because the inner join is only going to find the matching between the two tables, that will answer the question already. We don't have to do anything else. Now, if we did a left join, right join, and full join, that could change. And we'll see how both of those affect after we write the query. So let's do this first. So we're going to start with our select statement. Okay. And now we need to ask ourselves the question, which columns do we want to display? So we see the question is asking us, display the order ID. So I need to find the name of the order ID column. Order ID column does not exist in customers table. So I go to this orders table and I see there's this order ID here. So I have to copy this order ID column name, but I cannot have it written like that. So let me do this first. I'm going to write this in Notepad because I need to go back and forth on this, and this could mess up a little bit. So I'll do select, and there's my column order ID. And because this is coming out of orders table, the way I have to write this column name is first I write the table name, orders, then put a dot, and then paste the column name like that. Any question here? Okay.
Um, uh,
Mhm.
yeah, this is the inner join. So we're gonna display the common column which is common in both the table, right?
Yeah, I'm just thinking if the question was worded properly or not. But what it's going to do is whenever you say inner join, doesn't matter if you write the table name, which table name first, which table name second, it's only going to find the matching customer IDs. So how it's going to look like, let's say you got this customer ID 90. When you do inner join, it's going to look for this customer ID in customers table. This 90, and it's going to display that customer name and the order number. If this table, orders table, does not have, if this orders table, notice it, in this view, I don't have customer number 1. That means with the inner join, you're not going to see customer number 1. You are only going to see these customer IDs and their information. Okay? Just wait and see, and we'll clear up a little bit more. So there's our first column that we need to display. The second column we need to display is customer name. There is no customer name on this table, but there is a customer name in customers table. So if I go here, I see there's customer name. I need to display that table, but I know that I cannot write the column name like that. I have to specify which table it comes from. So I have to write the table name first. So I put a comma here. And then I write the table name, which is customers. Again, your spelling matters. One spelling wrong is not going to give you the answer. You'll get an error. So customers, see, I did not put S. That's going to give me an error. So it's customers table dot, and I can now paste it. Excuse me. Double click on customer name, Control C to copy, and Control V to paste it. Okay. That's it. That's all. That's the table is going to show you these two columns, order ID and customer name. Order ID comes from orders table, customer name comes from customer table, and we are done with the select query part 1. Second part, there is nothing new. We always wrote from. This is where you specify which table. And I just told you that you don't really have to specify any particular table first, your choice, because it's inner join. You write the first one, left one, right one. There is no left or right. It's just going to find matching ones. So why don't I just try to be consistent? If I wanted to make it look nicer, because I mentioned orders first, I could just say orders table. That's it. From orders. And because I'm displaying customers column next, I can just say inner join, then name the customers table. Okay. These are two tables that we're connecting. And my last but not, yep, last and least, you have to say on which two matching columns, which you have to find a common matching column. And you guys said it was the customer ID. So it's customer ID. Now here's the beauty of it. Here's a little trick. You just copy this first table from here. This will always stay like this. You copy the first table, put a dot, take the common column, paste it here, put an equal sign, copy this whole thing, paste it here, copy this customer's table, replace this here, semicolon, close it. All you're saying is this is my matching column from orders.customer ID that column should match, or I'm matching it on customers.customer ID. What with the dot, you're saying that this customer ID column, I want you to get it from orders, and this customer ID column, I want you to get it from customers table, and then find a match between them. And those are the tables. After you do that, you give me these two columns as a display. Any question? Okay, let's see how it looks then. And go in here and post it. There's our query. If I run the SQL, I got 196 records. It's showing me the customer order ID and the customer name as we expected, and only the ones that are matching between the two tables based on the customer ID. Okay.
Um, I have a question. Like, I mean, as for the diagram that you draw, like in a join,
Mhm.
it shows that it gonna display only the matching column,
It's not
right?
going to display the matching column. It's going to make relationship between them and then display. For example, if I go back, take a look at this two tables that we were looking at before, is that notice that we have customer ID columns in both of these tables. But look at this output here. Okay. We have customer ID 1 here. Do we have customer ID 1 in this table? We don't. Therefore, this entire data here is not going to get displayed down here. It's not. Because this ID does not exist in orders, it's going to get unselected. But because this number 2 and customer ID 2 matches here, this field data, this row, and this row of data is going to get analyzed. And it's going to provide that data over here. Notice this customer got selected for this new table. Notice the order ID, which is 10308, was selected, and the order date for that got selected. Okay, with me on this, Stanley?
Yes.
Take a look at this number 3. This customer ID 3 does not exist in this list. Therefore, this got completely thrown out. This got completely thrown out. Only that record got analyzed, accepted, and displayed. So if there is no matching ones for inner join, now this is only for inner join. Okay, that is only for inner join. Now, if I were to do left join, then guess what? All of this will get displayed regardless matching or not. And only the matching one is going to get displayed, which is this. And this is still going to get taken out. If I did a right join, then the whole thing changes to only this 2 is going to get displayed. And these records will get canceled out if these records don't exist here. If 77 doesn't exist here, this will get taken out. But because it's a right join, all this is going to get displayed down here. Make sense?
I have one question.
Mm-hmm.
So in case of inner join, we can join more than one column. Like we join the order ID with the common of the customer ID. So we can join the some other columns as well from any table.
Are you saying can we join more than two tables?
Yeah, no. Actually, not more than two tables. More than two columns.
Absolutely. Yes. As far as you want to display more than two columns, absolutely. How are you going to do that? Take a guess.
Actually, we should select the column from each of the tables. Then we should specify the table name. Then we should make the command like the inner join and the table name. Then on the table name and column names equals table name dot column name.
That's correct.
So yeah, so at the end we should write the common column of each of the table, and the from top three column, three command, it should specify the specific column and the specific table.
Here's a challenge question. Okay, let's start to play around with this query before we jump into anything else. I would like right here, I would like another column display right here called city. You guys brainstorm, give me the answer. What do I have to do to this query? How do I modify this query so that I see city column right down here? You just have to add. No,
table name
don't,
and
not from scratch, Raju. Just tell me what I have to insert into this query. Don't give me the brand new query because it's already there.
comma.
Comma where?
Select after the customer name, then again a
Yes.
comma.
Yes. Uh-huh.
Then the table name.
Which is?
The table name. Maybe the customers.
Correct.
That is customer dot city.
Dot city.
Dot city. You see, now if I hit run, look at that. I got that city column down here. So there is no limit on how many columns you want to display. I hope by 3 days of, at least 2 days of class that you have done, your biggest takeaway should have already been that right after select, all we write is the columns that we want to display. So if this did not stick to you yet, you need more practice. But you see, in the computer science world, everything is very, very consistent. There is no there's no gray area. It's either black or white. That select statement is only going to have column. This is where what you want to display, how you want it to display. Notice this, I specified 3 columns here. I got 3 columns here. I can specify as many. It might even give me duplicate. Like let's say if I write customers.city again, it might give me another city again. Let's play around with that. Let's see. I never really done that, but customers.city. Let's say for some reason I wanted to display another city. Okay, doesn't give me duplicate. Doesn't give me duplicate. But I wanted country. I can have country. Okay. So is it gonna change if I change the order of the table?
So why doesn't give it the duplicate of the customer city, or does it override the city on the city column?
I think this editor has limitations. You're gonna see today there are some commands that's not gonna work, even though I have to teach you, but it won't work here, like show databases command, because this editor is just a practice board. It's really not a real database. When you go to real database and you really want to have two columns, city column, yeah, you can force it. There's a way to do anything, any customization. So, but this one has limitations, so it won't allow you.
Okay.
It's not allowing duplicate. It's saying that you already chose city, maybe you made a mistake. So it's there for teaching purposes, so it's telling like, oh, maybe you wrote it wrong. Look again or make corrections again. But take a look at this. Pay attention to this, how many records we got, 196. What if I change the name of this customer table, order of this? So I write customers first. Is that going to change anything? What do you think? And then write the orders table. Any guesses?
Yes, definitely change.
Let's try. So run SQL. Nothing happens. Why is that?
I think both the table has the same data. That's why. I mean, same number of data.
And what we talked about,
The last.
two tables.
Okay. So on order, you go to the last order, and I think we should change the table name.
You can experiment, but what I'm trying to tell you is it won't change a thing. What I'm trying to get to it is it won't change a thing because you called it inner join. Again, try to understand what inner join is. Inner join, let's say you got 300 records here. You got 300 records here. You only got 196 record that have matching customer ID here and customer IDs. Just matching ones. 196. It really doesn't matter if I write the orders first, orders later. No matter what I do, the inner join command is only taking this stuff and displaying right here. Now, if I change this to left join, then it's going to give me all of this 300 plus whatever matched from here, and then this number is going to change. So watch this. If I change this to left join, and now run it, I got 212. Because not only did this give me this 196 that was matching, but it also gave me whatever was left here that wasn't matching on the left side because I called it left join. If I call it right join, and run it, it doesn't change anything because what it's noticing, this orders table, whatever this orders table was, the customer ID in this orders table, there was only 196 of them. All 196 of them match with customers table that had like 300 customers. And so because I said right join, meaning give me everything, well, it was giving me everything in the beginning already. Therefore, 196 is the max that this table already had in the orders table. So that number did not change. Now, if I call this an outer full join, full outer, I don't think you need to write outer. Just say full join. Let's see if that works. That gives me 212. That means it gave me all of them that was in the customers and everything that was in the orders table. But together, it comes out to be 212 because this one only had 196. Okay. So this one idea, one example, you can kind of see all of them are kind of the same. So you really don't have to relearn everything for this. Any question?
So if you look at the left join and the full join, the total number is the same. Does it mean that the highest number of table and highest number from a table is, whether it is left or right, will be similar to the full join number?
That is correct. So let's take a look at this customers right here. Now, in the customers table with the customer ID, we got about 90 records, 91 records in here. What it's doing is with the orders, you got 196. It's matching every one of this with an customer ID in customers table. So you got this 196 customer ID. They're repeating, by the way, because same customer may have ordered it several times. So you can already see this customer ID 80. Whoever this guy is had an order before, ordered it again. So there is a whole bunch of repeats in here for that. Repeat again. But there is no repeat in this customers table. Okay, there's like 90 of them, 90 customers. Now there are some customers did not never really order. Never really ordered. So when we did that inner join, it only gives you the name of the customers that made any order that exist in this orders table. That's when we got those 196 customer names. When we said left join, it gave us 212. That means it gave us the 196 customers who placed an order who exist in that order table, including it gave us a whole bunch of other customers that never really placed an order. All right.
From the
That's
other table.
from the customers table. Yeah.
Right.
It never really placed an order, but still gave it to them, displayed it to you anyway. Okay. Let's take a look at a few more so that it kind of engraves on you. Take a look at this question here. Display employee name, last name. So again, always focus on first thing is like, what do you want to display? I got this employee. What did I see here? Employee last name that we want to display. Order ID and order date for existing orders. That's all they're talking about. They're not giving you any more information. So you have to kind of analyze yourself. Employee last name, order ID, order date. Where are we going to find it? So let's go see. Now, you may or may not need a join, but that's where your analysis comes in. So based on those column names that you want to display, employee last name, obviously I'm going to click on this employees. And I see this employee last name right here. Okay. So in my notepad, first thing I want to do is I want to write down the name of the columns with the table so I know where am I getting them from. All right. By the way, let me paste this to you on the, it's on the PowerPoint, so you can, notes are all there. You don't have to write anything if you don't want to right now. So for my next question, and again, always write this down, guys. If you try to, if you think that you can do this right off of your top of your head, nah, you're setting yourself for a failure. And if you blame yourself that, oh, I'm not smart enough to do this, then you're wrong. Because you are, but you're not using your tools properly. We're smart because we have tools. We're not strong like animals, you know. But we have tools that we can use to make ourselves advance. Technology, paper, pencil, these are all tools. So you have to use those tools. And then if you're not successful, then you can blame yourself. But don't blame yourself if you don't use the tools. So first thing here, I'm gonna write down my first column name. I found it. It's called last name. And I see it's coming from employees table. So I'm gonna write employees. And you know what? Why don't you just go ahead and write the select while you're there already?
Just a small question. Yeah, just means the left table means the table that we're gonna mention at the beginning with the first. Is it like that?
No, you only the left and the right where you have to be careful with your which table you put in first. But we're still in inner.
Okay.
So no worries. Don't even worry about which table you write first, in the inner or the outer, okay?
Okay.
So select, here's my first one, last name, and it's coming from employees table, employee dot last name. There's my first column. I found it.
Employee or employees?
Employees, you are correct. Thank you. Good job. Next is order ID. Okay. Do I see an order ID in this table? No. So I'm going to be like, okay, where am I going to get this order ID? By the way, this is what the developers do, okay? This is exactly
Yeah,
what I'm doing right now. That's what they're going to
it's
be
from
like.
the order table.
Yeah. So let's go to this orders table. So they would take a best guess and like, maybe it's in the orders table. Okay, this may or may not work, by the way. So watch this. Orders table, do I have an order ID? Yes, I got an order ID. All right. So it will work. I'll say orders dot order ID. Okay. Any more columns they want? Yes. They want order date. Well, lucky for me, order date already exists right here. So I don't have to open up any more tables. I could just say orders dot order date. Okay. That's your first step. Is what do you want to display? Your select statement, display the columns. Now that you're done with this, the rest is actually very, very easy. But before you start anything, you know that you are now connecting two tables. That means you have to have one very special column that they have common in. They have in common. Which column in both of these tables are common?
It is customer ID.
Customer ID. Lucky for us, There's customer ID here and employees. Well, not really, GST.
Oh no, no, no.
Bummer.
I'm sorry. I'm sorry. I
No,
missed
it's
it.
okay.
Employee ID.
Employee ID. Okay, we got
Employee.
an employee ID here, and we go back to orders. Do we have employee ID here?
Yes, yes,
Yes.
we do.
Oh, we have employee ID. Okay, so that will work, but the customer ID is not going to work on this one. So we know there is a matching one, so we at least we know we can work with this. So let's go. Let's continue. Now, if we didn't have this employee ID in both of those tables, we would have to come up with a different table. We won't be able to connect them together. Make sense? This join command is not gonna be will break. It will get an error because that's the only way it works. Understand? It's like two people. They fall in love. They gotta have something in common. You can't join them together if there is not one thing common. I mean, there could be 9 things different. Yeah, that works. That's fine. But for that love to exist, at least there has to be one thing that they both share. Same thing for this SQL join. We found it. We found employee ID, that one thing that matches. And we're going to work on that. Okay. So now the rest is easy. Here. Next step is from. Your choice. Which table do you want to name it? Well, I got this employee first. Why don't I just copy that and paste it here? I don't want to make my life hard. And then I'm going to say inner join. Well, I already wrote the second table right here. Why don't I just copy that? Post it here. Okay. The last part, what do these lovers have in common? We know that we saw employee ID is common column in between them. Well, I can't just write employee ID. I have to write, that's the rule. I have to write this table name first, so employees table name. But at this point, you just do copy paste. That's it. There's no more brains needed. You just copy paste it from what you already have. And then put a dot, give it that name, employee ID. Put an equal sign. You're saying this column to match with that column, but coming out of orders table. Okay. This is Emily. She has a column employee ID. This is Jason. He has a column employee ID. They got this matching thing between them, so this relationship is going to work. All right. Now if I take this, copy this, and paste it here, and run the SQL, and you got your answer. You got all the last name, order ID, and order date, and based on matching criteria between them. Question? Seems pretty straightforward. Let's jump into a left join example. Again, we display all records from the left side, matching records from the right side only. And here's a question right here. It's called display all customer name, order ID with customer names in descending order. Watch this wording right here. Display all customer, excuse me, display all customer IDs, customer names, sorry. Let me get this pen tool properly here. So this all customer names. This is where it's giving you hint, hint. Okay, hint, hint. That means they want all 91 customers. This is your left join right there. Okay. Meaning you want to include every customer. You cannot have skipping a customer. If you try to do inner join, it's going to find matching customers. It might skip a few customers that don't have matching records with this order ID. So watch out for this all statement. Whenever you hear the all, that means that's what you're going to include everything of. And then you got this order ID. Okay, customer name, order ID with customer name in descending order. So it's also asking you one other thing to add is you display the name in descending order. So we're going to add that in there as well. So let's work on this. You need to first investigate the tables. We know we're going to get our customer name from customers table. We need order ID. We can get it from orders table. Now we need a matching field between them. I see customer ID here. Could be the relational field. And there's customer ID in customers. So it looks like it's going to work. Let's start. First thing, again, how many columns do I want to show? So I want to start with select. First column I want to show is customer name. Coming out of customers dot customer name, comma, I want to show orders dot order ID. What was that? Yeah. Order ID. Those are the two columns. Because I want to display all customers, that means I want, if this is my left table, I want all this left stuff to show, not just the matching ones. So give me this from, this would be my left table, which is customers. And then I'm going to say left join. If I say left join, then that's going to give me this as my left table, and this would become my right. And that will be orders. And now I'm going to say on the matching field. The matching field is this customer ID, but I can't write customer ID alone. I have to say which table is it coming from? Customers dot customer ID. And then put an equal and then say orders dot order ID. Okay. It doesn't end here because the question also asks you to order them in descending. Who can tell me what other command I have to write here to display order by? Correct. So we do order by. How do I do this?
Well, order by
or descending?
Yeah, DSC, customer name DSC.
Correct.
Customer, yeah.
Correct. You have to specify which column you want to order by first before you say ascending or descending, and because they want it by the customer name. Now again, you see, it will be safer just to say not customer name, but you have to specify which table it's coming from. So you have to write customers dot customer name and then say DESC. Because you're joining two tables, now every table name comes first. Okay. By the way, if you always wrote it like this, it won't give you an error either. So even if you didn't do left join, right join, or any kind of join, if you get a habit of writing the table name first with a dot and then the column, it works. As a matter of fact, you're going to see in Java class how we use this dot thing. So this is a little bit of a warm-up for you as we get into Java next week. So let's copy this, paste it here, run the query, syntax error, could not prepare statement. My
Yeah, it's
spelling,
because I think orders dot customer ID
no, just
in
you
the
see,
fourth line.
it's already telling me my spelling is wrong.
Oh, is it? Oh, all right.
You see that? My select spelling is wrong. So I go back in here and fix this. Oh, I have to say okay first. There you go. So select, now run it, and I got 90 records. Look what happened. Because we did left join, it gave me everybody from this customer table, all 90 of them. But they don't even have any orders. Look at this. A lot of these guys don't even have any orders, but they still gave it to me because I want it. But there's a whole lot that has orders. Oh, this is wrong. There's something wrong here. It cannot be all null. Did I make any mistake? You guys let me know if you see any kind of errors here.
So on the fourth line on.
Mm-hmm.
So in on statement, the left column and the right column of each table should be the same or not.
You are correct.
Yeah, that I was telling you earlier.
You are correct. So it didn't match. I did not write it properly. Here's my customer table, and that's the customer ID. They have to be a matching one because they did not match. It did not work. Customer ID. That's the mistake. At least I hope so. Let's see. Correct. Good job. But I do expect some null right here. Look at this. Because this customer never ordered. But I wanted left join. I still wanted this guy to display. This customer never ordered. With left join shows me all of that. But watch this. If I say inner join, what's going to happen? Take a guess. What's going to happen if I change this to inner join?
It will be the same.
Will this
No,
number
there
be the
is
same? Or will this
no.
go down? Or will this go up?
It's leave those records, those who doesn't have any orders.
Correct.
Oh, see,
All
it
of
will go
these
less.
now, correct. The number is going to go down. That's when what's going to happen is these unmatched ones that did not find any kind of order but still gave you because you wanted every data from the left table. That data is coming out of the left table, but it didn't have anything in the right table. It just told you null because it didn't have a data in that right table, but still displayed it for you because you wanted that left thing. But if you just say inner, that means it's only checking for what's matching, and these are the matching data. The null ones are not matching, so this will get left out. Watch this. I run it now. This 220, 212 will turn to 196. And now if I scroll down, you won't find any null data. Any question?
I just have a question. What is DESC?
DESC is short for descending. So when we order things, there's two common ways to order things, okay? Order data, order string data. I don't want to say the word string yet. Order data, keep it simple. One is called ascending. Ascending when in alphabet A comes first, then Z comes. So you go from A to Z. Okay. And in SQL, the symbol is ASC. Descending is when you go from Z to A. Right? In SQL, is DESC. If it's a number, this is where you go from 1 to, let's say, 99. It doesn't stop at 99. What I'm saying is small to large. So small to large. Example could be like 1 going to 99. Descending is opposite, large to small, going from 99 to like 1. Shanjita, did that make sense?
Yes, but I just wondering if we don't put it DSC, then what's happened?
Like in this query, if you don't put DESC,
Mm-hmm.
then you would have to take this whole thing out, right?
Oh, okay.
Because this whole thing is, what are you doing here? You're saying order by. This whole thing worked fine. I mean, this would have been okay if you take this whole thing out, let's say, and you run this. Look what happened. Willman, Federico, Hanari, there is no order to this. Whose name came first? It's all mixed up. But if you wanted this name of the customer to display to you in a nice alphabetical order, then you can order it. You just have to tell it to order it. And the way to tell it to order it is where you write order by, and you have to give it the column name. And we said the column name is customer name. But again, you can't just write customer name. You have to also say which table. Table dot column name. So table is customers table, and then dot the customer name. And then you decide how you want to order it. We could order it ascending, ASC, meaning it's going to start with A first. And look at this. Now we have Anna, Antonio, a nice and beautiful order.
Yeah, thank you. I got it now.
You're welcome. Any other questions before we move on from here? Okay. I hope you understood what left join is. I don't think we need to do more examples. I do have more examples here, but we're just gonna zip through this really quickly because I feel like you guys got this. Right join, you guessed it, same thing, just the right side table. We'll do a quick example right now. Here's the question. And let's analyze this question. It's asking display existing order IDs. Existing order IDs. Right? So it doesn't say all order IDs. See, that's what I'm trying to get to. It says existing, kind of like matching order IDs. But look at this. all employee last name. So I know wherever I'm getting this last name, I gotta display all of it. And first name. So this is another column name with last name ascending, but that's something different. This is not gonna mess up my table formula, table display, table join formula. That's easy. But the technicality is right here. Only the existing order IDs, meaning employees that have the order that they placed, and all of the employees' names. So maybe they're also trying to see which employee did not make any order. It's going to give you some null. It's going to give you all the employees that have an order placed with the customer. Also give me employees that didn't place any order. So I can kind of see who's selling stuff, who's not selling stuff. That could be a real world situation. So let's go ahead and start building this query here. Get the notepad out. And we're going to write this down. So obviously, first thing you want to do is select. All right. We need this order ID. So we saw order ID came from orders table. Employee last name and first name. That's going to come from employees table. I just don't know how the column name is written. So I'm going to go into this employees table, look at it, and be like, okay, they have a last name column and they have a first name column. We're going to take those. Noting that this has a unique ID called employee ID. That means we're going to match that with orders. Also has this employee ID. So they will match. Now going back in there, we're going to write employees dot last name and then employees dot first name. That's done with our columns that we want to display. Over here, we're going to mention from which table. Now, this is where you have to be a little careful because if it's a left join or a right join, where you put the table name matters. How do I do this then? This is what you need to think about. You are thinking about this all employees. You want to have all employees stuff. That means you have to display everything from that all employees. All right. So if you want to make this the left and use the left join, that's fine. But if you want to make this the right table and use the right join, that works too. Your choice. But for this example, I'm going to make this the right table. And this orders, I'm going to call it the left table. Therefore, I need to write this left table first, right here. And then I'm going to say right join, and then I'm going to use this right table to the right side and include everything. So when I say right join, and immediately after the table that I'm going to write, it's going to give me all data from that table. Therefore, I'm going to go in here and I'm going to say from orders. I'll do both for you and you'll see the answer comes out the same. And on the homework, I don't really care how you write it. As long as your logic is sound, you get the point. So from orders, I'm going to say right join. This is where I'm going to put employees because I need everybody from this guy. Employees. And this is pretty easy. On which to matching table, first you write orders. And this one, order doesn't matter, by the way. I can write employees here. SQL doesn't care about this, which table I write here first. I could say employees dot employee ID. That's the matching. And then say orders dot employee ID. Totally okay. If I want to flip this up, it won't change a thing. That is not, does not matter whatsoever. But these two matters. Results will change. If you use left join and right join and you don't know where to put the which table, your results will change. Now let's copy this and take a look at it first. Before you make this query any farther bigger, run it. You got 197 records and you got all of these customer employees. Do we have any null data? We don't. That means, oh, there. Adam West. It gave me Adam West's name from the right side table. But from the left side, which is orders table, he never sold anything. So it's telling me null. Wasn't able to give me this order ID field. Okay. Things are gonna change if I change this. If I change the order, if I change this in right to left, let's see what happens. What I'm expecting is that it's gonna look at my orders table. It's gonna only check for the orders that's there and not even gonna give me anybody who has null, which is this Adam West. Adam West is gonna be gone. He will get fired, by the way, because he's not selling anything. So if I run SQL, I got 196. I scroll all the way down. Adam West is no longer there. Because it's only looking for, it's giving me all the orders and skipping the employee on the employee table that didn't have any order. Okay. Let me put it back to, now let me leave it like this. But I can switch these tables right here. It will bring it back to my right join. I can say employees here and say orders here. Now what just happened? Now this employees became my left table and orders became my right side table. Well, I know I got a lot of orders here and I am doing a left join. That means I am taking everything here and only matching ones from here. Well, what's everything here? Well, everything is like all the employees, including John West or whatever, Adam West. He's not selling anything, including that guy. So I'm still gonna see that guy because I'm taking all of that. But he didn't make any sales on this table that I have the orders with. That's still gonna get displayed. Watch this. 197 right there. And if I scroll all the way down, there's Adam West. Understand? So left join can be written as right join. It depends how you order your tables. And you still get the same answer. Now I'm going to turn it back to right join because that's how it was. And I'm going to make it ascending because that's how they wanted it. So orders right here, employees here, run it, make sure it works. And Shanjita, how about you tell me, what do I need to write here to order this by the order ID in ascending order?
I think order by employees.
We're ordering it by this column here.
Oh, order ID.
But can I write order ID right away?
No, I think order ID came from order ID from orders.
Good.
Dot order ID,
Mm-hmm.
and then I think ASC.
Yes. Good job. I run that, and I got this. Because null is like this, no number at all. It's not just the smallest one, but it doesn't even have anything. Therefore, the null gets displayed first. And then the smallest number of the order ID, which is 10 to 48. And if I scroll down, the biggest number is going to be at the very bottom. Any question?
Just to know, like this is the same logic like the VLOOKUP of Excel, right? It's almost similar.
Similar.
No, thank
Yeah.
I have another one question.
Uh-huh.
That is, if I make more than two or more ascending or descending query, then how does it comes? Like we only did the order ID ascending or descending, but if all together with the last name and first name ascending and descending together with the order ID ascending and descending, then what will happen? Or can we do it?
Sometimes it's not possible, right? Like let's say if this column is unique, and which is the case right now, is that all of these order IDs are unique. And they have already been sorted out. And you have this as ascending order. You won't, even if I try to make this one ascending order here with customer name, it's not going to work. It's not going to work. But let's say if I had same order IDs, like 5 of these here, okay? So 259, 259 here, imagine 259, 259, and 259. Now you are able to do an secondary ascending order on this column. What's going to happen is, see this name right here, Peacock? It's going to take this chunk and it's going to say, I want to put this C or Callahan right up here because it comes first. I want to put Dodsworth here. And then I want to put these two Peacocks down here because all of these customer IDs match. At that point, it won't make any difference. You still have this ascending order and you can still have a secondary ascending order. But for this particular, so answer your question, yes. Can I have ascending order in multiple columns? Absolutely, you can. Question is it always going to work? It's not always going to work.
Yeah, it makes sense. It makes sense. And if we would like not to repeat the name, but the number of orders, like the distinct and name, then can we make that comment to not to repeat the name repeatedly, but only one name and the number of order? That means
Correct. Correct. You can do that too. You can use the word distinct, but notice um, you can only do distinct in one column. Okay, you can't do multiple distinct. But if I wanted to do distinct, notice that this is already distinct because it's unique. What's not distinct is here, but I can't specify that to make this column distinct because it may or may not work. I've never really tried it in here, but looks like the join might get in the way of saying, hey, I got this matching right here, but you want distinct, that which one am I gonna leave out? Am I gonna leave out these two and then just give you that? Or leave out these two and then give you that? But I'm still leaving out two valuable order numbers. And the SQL might be worried that why would you even wanna do that? You know what I mean? So
Yeah.
this whole join, when you're joining tables, I never saw a distinct application where they needed a distinct, because the whole point of getting the join is to combine and get more results, because we wanted to see. Now you can group this. You can probably group by and then sort, and you can like collapse these three into one by this name, and then it's going to show you three order IDs. You can go a little more complicated display, which I'm not going to, this is out of the scope of today's class. I might throw you off a little bit. That's why I'm not going to go there.
Okay, that makes sense.
Yeah. But I think you got this, whatever you got so far, and I see you guys are asking good questions, so I'm really happy. That tells me that you're digging deeper. And with the knowledge you have right now and the understanding of how SQL works, you are on your way very well, successfully to work as a QA automation engineer. So I have no doubt. Okay. One last one, and we jump out of this one. We're going to do this full outer, so we're going to go this really quick now. Let's take a look at this here. Look at this. Display all records with customer name and order IDs from customers and orders table, including matching IDs. So all including matching IDs, that is a hint telling me give me everything. Okay. If it only said display only matching records, then I know inner join. But it's saying all and including, it's a hint, give me everything. So we're gonna do that with the full join. Opening up the editor. We start with which tables we're gonna need. We need customer name. We know that's gonna come out of customers table. So at this point, we have a little bit of experience. We say select
So
customers.
should we use full outer join or only the full join?
Full join, full outer join, it only depends on the type of software that you're using. Now there's a whole lot of SQL softwares out there. I don't know if you watched that first video completely, the first PowerPoint that I missed with you guys. I touch base that again in when we get to Selenium. Each software may have a few tweaks or few code differences of their own. So that's why I wrote full outer join. You may have to use both of them, full outer join. You may have to use just say outer join, or you may have to use full join. Either way, the variation is right there. In this editor, it might allow or may not the whole combination. We'll experiment and see. So customer name, that's our first column. And then we got this order ID, our second column. So we'll say orders.order ID. And that's it. That's all they wanted. They wanted everything. So we know if it's everything, it doesn't really matter which table I write first. So from customers table, I'll just name customers because that just came in my mind. Because I'm careless right now on which table I put first. Inner and outer are the easiest ones. So I'm going to say outer join or full join. I don't know whichever software allows me full join. I'll see if that works. Full join, and then I'm going to write the next table, which is orders. Now you have to find a relationship between those two couple. And we pretty much know that customers table has a column called customer ID, and orders table has also customer ID, and those are common between them, so it should be fine. Any question?
Are we not going to display customer ID?
Do we want to display customer ID?
No, I mean as per the questions, it's want everything, right? So the customer ID need to be displayed or no?
Display all records with customer name and order ID from customers. Because we're joining, and when they say display all records, it doesn't really mean display all columns. So I know, Stanley, it is confusing, but I want you to think it like this. All records does not mean all columns. Okay. All record means all either matching or not matching. Now, looks like to me they're specifying they want customer name and order ID only. And it is going to be a tedious to display all columns. Now, if they say display all columns with all records, then you have to list every single column name that's there. And because you have to specify the table name and then the column name and the table name and the column name, imagine how big this is going to get. And you can't even put a star saying all because now you have to write the column name, table names. So this star thing doesn't work here. It's not going to work.
So one thing I think one thing has been repeated. Actually, it was not necessary to add like the including matching customer ID because it already says that the customers from the customers.
So if you want to, I'm thinking maybe they're just trying to say that this is going to be your matching field. But again, I'm not really picky about the question. So if you feel like you want to display this just to be on the safe side, I would say go for it. If you have a doubt, go for it. To me, it feels like it's trying to hint you that this is the matching field, matching column you want to use as where they match, but doesn't really specify that you really need to display the customer IDs. But for this particular case, if you have a doubt, go ahead and add that. I'm going to go ahead and add it. So I will add customer ID. Why don't I add the customer ID first? It might look nicer. Customers.customer ID and comma. Okay. Good so far? Let's take it. Put it into the editor. Run it. There we have it. Customer IDs. Customer name. There's the order. Never placed an order. We got all of that.
Okay, if you don't, if you withdraw the customers dot customers ID in the select query, then what happens? I think
Then
it should be also 212, probably, I'm not sure. Oh, only that column will be withdrawn,
Only the column will be gone. Correct.
but the
So
total
fine.
number will be the same or not. Can you try?
Yeah, it will be the same.
I think so.
One
Okay.
question.
Mhm.
So for full join, it doesn't matter actually what table we're going to choose as left table and which table we're going to as right table. It doesn't really matter.
That's correct, Raju.
Okay.
So if I switch these two tables here, I write orders first and write customers. My result, same. Same 212.
I have a question, right?
Yeah.
So, I mean, in these two tables, I can understand that the number of records should match with the table which has the maximum number of rows, right? In these two tables, because this is so simple. But is there any way that we can verify the data that what we are expecting that's correct with the codes or something?
Yes, you can.
Okay.
Through Java, which you're gonna
Okay.
learn, which you're gonna learn towards the end of the Java class in about a month.
Okay. Understand. But this one I can understand that it will be 212, which has the maybe either one has the 212 rows, so it will give you the maximum.
Yes.
Yeah. Okay. Okay. No problem. Thank you.
Just to tell you that 2 days ago, I had a test case where I had to do a query and I got 138 customer IDs like this. And I had to match that 138 customer IDs with a list of customer ID on the website. So I was like, my eyes were hurting because I was doing it manually. I'm matching here, this one, does it have any other one? So I called my wife and I'm like, can you please come and help me? And then she came in and I gave her the website and I was looking at the database and I tell her, hey, 10248. She's like, yeah, got it. I'm like, 10249. Yes, it's there. 10250. Yeah, that's one there too. You see what I mean, it's as simple as that. You might think, oh, these guys are engineers and they make so much money, they do so technical stuff. Really not. Piece of cake stuff. And you make good money doing that. And I had my wife help me out with that. Now, I have a test case for that. I wrote it down. I wrote down the steps in Gherkin, and I'm going to automate them using Java. So in Java, what I'm going to do is I'm going to take this table right here, take this column, customer ID, and I'm going to put it in a list storage, which I'll teach you how to do that. And then I'm going to take the column customer IDs from the website, and I'm going to put that in a list. And I'm going to do a Java method to do a comparison. It's going to do an analysis. And it happens within a second. After you write the code and you run it, it takes lightning speed for Java to go in and look at all these numbers and do its analysis and either tell you pass or fail. And you can design how you want this pass or fail. It could even say fail, and we did not find these two customer IDs here. You have full control. With Java is so powerful, you have full control of how you want to compare these data. And after comparison, if it fails, how you want to display the failure. Totally. I mean, it's magic. which you're about to see next week, starting up. Next topic we have is not as complicated, even simpler, and that's called union. Anybody needs a break right now?
Yeah, it is better if you can.
All right, let's take a break of, we'll come back at 11:15. All right, let's get started. Our next concept is union. And union is basically connecting two SQL queries into one. It's kind of like joining, but you will see that the whole syntax is a bit different. So the things that make union a different is you are going to have two select statements here. It's like two independent select statements and you connect them together. Now you can connect them together with the word union, but you have to make sure that the number of columns in both of those select statements are same. You cannot have mix and match column names for both of those statements, but you can have two different tables. Totally not a problem at all. The order matters. You'll see some of that come up, and the data type also have to be same, meaning what are you displaying? So that again, this condition have the same data type goes back into the number of columns that you're going to display, and really nothing extra, but you will also see how that comes into play. Let's take a look at the syntax. Here's the syntax of one, and there's two types of union. One is just union by itself. This, if you just write union, then it's going to give you matching values from the first one, only unique values from the first and the second one, second table. And that's why this is called the distinct union, distinct data, unique. But if you say union all, like this one, if you put union and this all command, then it's gonna give you data from first table and last table, whether they match or they don't match. It's gonna give you all data. Let's take a look at an example. Here's the first question we have. It's saying that display distinct, it's telling you distinct matching cities. So they want you to display only cities. So we already know this is going to go into our select statement. And it's telling you which two tables, coming from customers table, coming from suppliers table. And then they're saying order it by the city. So that's not a big deal. Don't focus on this part first. Always do this last, order by city. Yeah, you can just add that in there. But the technicality is that you're going to display all the cities, all the matching cities, distinct. So obviously you're not going to take this all, you're going to take this union command and then carry on with creating the SQL query. Now, you may be asking, well, why don't I use join? Why am I going to use union for this one? Any idea why you might be using, anyone want to take a guess why you might be using union instead of join from customers to suppliers table? Maybe I can even ask this question. Can we even use join? Is join possible? Let's take a look at these tables. Here is suppliers table. This is suppliers table. And this is customers table. Will I be able to write a joint query for customers and suppliers? Yes or no? Why not? Take a guess.
No common ID for both the tables.
So what are you saying? Because they don't have, give me the full sentence. You are right,
That
Raju.
means
You're in the right track.
there are no common actually column for both the tables.
Yes, I want you to get these words out of your mouth. I know it's in your brain, you got this, but you won't be able to verbalize it if you don't practice. You see, you might be thinking, oh, Stein is like this teacher material and he just has this ability. I promise you, I did not have this ability to speak like this just from dropped from the sky. No, I, I was like you one day, and the only way I got to this is because I've been trying to say what I'm thinking. You have to practice that. So your communication matters. Uh, Sometimes you may need to just kind of say it to yourself, maybe you whisper it to yourself, and then practice it that way. I promise you, it's not the same. Our thought process and what we verbalize doesn't always come out the same until you really practice it. So you have to give yourself that practice. And this class communication is very important. I urge you to participate in this class communication because this gives you an opportunity to practice what you're thinking. So these are educational words that you're speaking in. You're talking to me in this SQL query language, and this only will get better the more you talk to me about this. And you are right, Raju. There
So
is no.
I need a little clarification.
Mhm,
Like for the select or union.
mhm.
So in case of union, what should be the condition that one or more column of each could be the common column or not?
Well, you cannot union two select statements if they have multiple columns getting displayed. You'll see that in just a second. But most fundamental thing, the reason we cannot use join that we just did before is because customers table does not have a matching column that we can join them on with suppliers table. Even though suppliers have this supplier ID, customers table does not have this suppliers ID column.
So can you please
And,
go to the customer column?
sure.
I think the CD is the common for customer ID, and is it not?
So let's see. You're saying there's a city column here. How about a city column in here that we can match? Even though we have these two columns in here, but are they one of those unique ID fields? Are they one of those unique ID columns? They're not. You won't be able to join them based on this matching because it's not one of these, like these have to be a special ID column that you have to match it by
So,
for it to work.
so my question here is that
Hmm.
how, so should it be compared manually by seeing what are not the common or is different from one table to another?
Yeah, I mean you can do it manually if you want to, but then you have to go back and forth, and that's going to be a lot for you. But
Yeah,
understand,
because,
hmm
yeah, go ahead first.
yeah, the question, you see, the whole purpose of the question is an executive is trying to say, give me all the cities from customers and suppliers that match. So they might want to say, let's say New York match. Why do they want this New York? They want to see that these customers, these cities are very popular cities where we can do a lot of businesses, where suppliers are residing here and also our customers are residing here. We don't have to deliver this product too far. Maybe that's a decision they want. understand that we got this table here called customers. Let me do it here. And we got customers from all over the world. And we got this table here for suppliers. But suppliers are not all over the world. Suppliers are probably only in the USA somewhere. Okay. So you might not want all the list of the cities from the customers. You only want to see the list of customers that are residing in the same cities as the suppliers. But how am I going to find a comparison? How am I going to connect those two and do an analysis? There is no matching columns that we can join them on. That is like customer ID or supplier ID. They don't have a sharing unique ID columns. Okay. You can't just do it by the city. City is what we're going to display. So this is why this question is a good candidate for union, because with union, you can connect them together. So watch this. How are we going to do this? For union, you do one thing at a time. First, you create two SQL queries. So your first SQL query, number one, you display the cities that it's asking you from customers table. So somebody give me a query to display all the cities from customers table. Just verbally tell me.
So select then the select
Mhm.
space
Customers.
customers.cd.
Mhm.
Customers, right?
Yes.
.cd.
Finish it.
Yeah, colon, semicolon, right?
No, you have to finish. You have to give me the whole query
No,
Oh,
then
from customers.
from customers. Correct. That's one. And then you take another query. Give me another query. This time you want the city from the other table, the suppliers table.
Yeah. Same thing. Select
Mhm.
select the suppliers.cd from suppliers.
City from suppliers. Okay. So let's see how this looks like. Let's take this first one. Put it in here. Run it. Giving me an error. What is it saying?
Suppliers and customers, the field name.
Exactly, customers.
Yeah, I got the spelling wrong.
Yeah.
Customers. Run it. I got 90 cities. Okay, it's working. So that's good. Now let's take the second one. So I gotta fix that here. Take this one. Copy. Paste it in here. Suppliers, plural, I think, as well. Run it. Working. Good. 29 cities right here. Now we want matching cities, not all of them. It could be possible that there could be one customer or no customer lives in this Ann Arbor city. Then I want this to be out of here. If I have a customer living in Melbourne, I want to see that city. But if no customer living in Berlin, I don't want to see that city. That's the whole point of this query. So if I connect these two together with union, it's going to take those cities out that are not matching in those both queries. So I can now just go ahead and delete that. Just copy the first one, paste it here. I don't need the semicolon. So I take the semicolon off because I'm going to connect them together. I'm going to write union. And because I want it distinct, so I'm going to leave it as union. Otherwise, I could say union all, meaning give me everything, all the cities from customers table, and matching or not matching cities from suppliers table, but I'm just going to leave it as that. Copy this, paste it here, and now ending with the semicolon right there. Okay. If I run it, I got 94. So there is 94 cities that got listed now where my suppliers live or the product suppliers are located and the customers are located. With this list, I could make some decisions like maybe provide discount for these cities on delivery because I got the suppliers living in the same city. One of many things that a manager can do with these two queries. Now, if I say all, is this number going to increase or decrease?
It will be increased.
It'll be increased. So if I say all, now it doesn't care whether they live in the same city or not. It's just going to give me all the variety of cities. I got 119. Well, I can still use this data for something. What thing? Well, I can use this data to decide that, oh, these are the cities where my customers are, where my suppliers are, and I should only do businesses in this city. Or I should provide marketing strategies on these cities to increase businesses in these cities. One day my executives might want to see if, you know, if Dallas is in this list or not. I can type Dallas, and this is there's no Dallas there. Okay, but they might want to have this list to compare against another to see if they need to expand their business. How many cities they want to know? They can do that. Okay, let's take a look at another example. Display all matching cities from customers. Oh, that's just the same thing that we just did. Here's another one. Get a list of customer, employee, and supplier names. So list of customer, employee, and supplier names. Look at this. How many names we need. How many tables do we need here? Here's customer name coming from customers. Employees names coming from employees. And supplier names coming from suppliers. We got 3 different tables. Well, good luck. Good luck trying to join those 3 tables. Because good luck in finding a matching column with unique IDs like this. In all 3 of them, join is going to get all confused and messed up. A better option, union. Have 3 different small statements to display all these names. But again, your column, it has to have a matching number of columns. You cannot have different columns. So different number of columns in each of those statements. So let's take a look at this. We want this customer name. So get a list of customer, employee, and supplier names. We got this customer name. We're going to take this one. From that, employees, we're going to take, we cannot take last name and first name. You have to choose one. You have to choose one. So how about just that first name right here? Suppliers, you can take supplier name. You can't choose supplier name and contact name. You have to choose one. Now, if you choose 2 columns in all of them, that's fine. You can choose 2 columns and then you have to have 2 columns in every statement. Let's just stay with one. We're just going to take this one first here. So go go ahead and tell me what would be my first query here to get the customer name from customers table. Select what?
Customers dot
Go ahead.
customer name,
So customers dot customer name.
comma,
No, just one.
then
Just
yeah,
one. Finish the query right here.
from customers,
Good.
comma, suppliers.
No comma.
Oh, it's done. Yes.
That's
Then
one.
semicolon.
That's
Yeah.
one. Now you
Yes,
say
and
union, and this one did not say distinct, so you're going to do union all.
okay.
Union
Then
all. And then you go to the next one. What was the other?
suppliers. Yeah, suppliers dot suppliers name.
Again, Sanjita, you need a brand new query.
Oh, okay.
The whole
Select
thing about union is you have to have brand new query to start from the beginning. Select
suppliers
suppliers.
dot suppliers name from suppliers.
Yes, supplier name, and I need to go back and double check this, but let's go ahead and write it right now because I could be wrong here and that could be a problem. So from suppliers.
Comma. This time we need comma,
No
right?
comma.
No?
No comma.
Okay, then
Again, another
select
one.
select employees.
But pay attention that I put another union all. And then I'm going to do select employees dot
employee name from employees.
Employee name from
Employees, this time semicolon.
Yes, employees and semicolon. Now, if I hit run SQL, I'm pretty sure it's going to give me an error. See that? And it's telling me no such table customer. All right. And you got to fix that. Here, I got this no such table called customer. That means I wrote it wrong. I got to put an S right there.
Customers, yes.
Run it again. Next thing, no such column called employee.employee name. So see that? No such column called employee.employee name.
Employee, I think.
Well, my guess is this table name is correct, but this column name is not because there is no column called employee name. Maybe it's called first name. Maybe it's called last name. We need to go check that. So I'm going to open up another window. I don't want to mess this up. So I'll leave that there. Maximize this. And let's go check. Here's suppliers. No, sorry, employees. Here's employees. Do I have, what's my column name I want?
First name or last name?
Yeah, let's take first name. So that's what I have to use. So I copy that, go to my this tab, change that to first name. Run the SQL. Now it's happy. Here we go. All the names got combined into one. Employee name, customer name, supplier names, all in one. This is the use case of union all. There is no limit on how many SQL queries you can union together. Only thing you gotta be careful is every one of this query must have a strict number of columns to display. There's only one, and only one. If I put a comma and have another column name here, that's going to give me an error, and it's not going to work. But if I had two of them, for all of them, I had another column here, another column here, another column here, it will be fine. As long as I have the same number of columns from all those tables. Next
Show an
concept.
example for that.
Um, I don't have it in the homework, and I really don't need to. You don't need to worry about it. It's too much. And I might really, this class will become very long because I got a ton of stuff here. So,
All right.
Chisti, please forgive me. Yeah, it's a heavy class. So here we go. The next thing we need to cover is some of the basic stuff that we did not cover of creation. How do we create tables? How do we create database? Again, this is not a QA's job, but I'm still teaching you anyway, just in case you don't black out if you ever had a question or something. So take a look at this database. Now this, creating a database, showing databases, there are some commands there that database admins generally use to create a database, and you're also going to have administrative access into that database to do that. And generally, you as a QA, you're not going to be given the admin rights to even do any of those operations. Here's a thing you can do. It's called create database. This is the very first command database admin will invoke to create a database. They would write create database and they give it a name of the database. Again, this is for the creation. It's like the Genesis in the book of creation. God creates the world. That's the create command that they would do it. It doesn't, they would only invoke this one time to create a database and then go inside and create table. So if I wanted to create a database called testdb, then the command is going to look like this: create database, and then type in the name testdb, and that's going to do that for you. Now, there is no, this does not get, you won't be able to do this here in this editor, by the way. It doesn't allow that. See, if I type in create database testdb and run it, it gives me an error. That doesn't mean it doesn't work. It just doesn't work here. It won't let you allow to create another database because it already has a database created here for you, which are these. So it won't allow that. It's designed that way. Some things you can do. You can delete a complete database. Again, you need special permissions for that. And to delete it, instead of writing delete, it's drop database. That's going to delete the entire database, which is very, very scary. For anybody to use this command, you better know what you're doing. So if you wanted to delete a database called test database, then you would write it like this: drop database test db, and that will delete everything that's there. Very, very destructive command. If you wanted to see what's inside a database, your command is show databases. Let's see if that is supported here. This is a good command. I like to do this command to see what tables are there and what not. Show databases. No, it doesn't support that. But when we install MySQL in your computer, you would be able to use this command called show database. And it will basically show you this. It will tell you how many tables, which table, what are the table names, how many records there are, and so forth. This data will get shown. And you can also back up your data for protection in case somebody deletes it. And the command for that is backup database. You name the database right here. You specify to disk equal to and provide a file path where you want to store all the information as a backup in case somebody deletes it. You can always retrieve it from there. None of this is in the homework. Okay. This is the file path, and it's going to look like this. I just wanted to mention it so you know what it is, but you don't have to do anything. A little warm up on something called data type. When you create a table, when you create a database, you have to specify which column has what data. Please ignore this right now in this part here. It just didn't come in properly, but I just want you to focus on a couple of things here. More on that, we'll talk about it in Java class, but there is something called a primitive data type. Primitive means old. This data type of string coming from very beginning, this data type of string means what they're talking about is characters, okay? Alphabets, letters. All of that is wrapped up in this word called string. So whenever I tell you the word string, it means characters. Okay. In SQL, it could be called string. It could be called varchar or varchar. Char is the short for character. Var is the short for variable. This is how they like to name it. Or it could be called char. Okay? So just keep that in mind, in the back of your mind, that when you create a table, you have to specify that table is going to store what type of data. And it could be any one of these: string, varchar, or char. Why did they name it like that? I don't know. But they named it like that. They took short form of few words, put it together, and this is how they named it. In Java, we're going to be using something called string. So you will see a big use of this string word. Java also has char. One or two cases we will use char. The difference between the string and the char is just a character like letter L. This is going to be a char. But string can be letter L or more. So string could be, let's say, the word lost. This info is not going to fit in here. This would be just a char, meaning one character. And if you have more than one character, like lost with that L word, this would be placed in a data type called string. String is basically one or more characters together make up a string, and character char or char is just one character. I just wanted to kind of give you a bit of a warm up on this. Really not needed so much. Forget about these stuff. I have it in there. You're not going to need it. But let's take a look at this string and char. I'm going to skip a couple of these we're not going to need. I do want to show you this one here. Pay attention to this data type called int and float. Int is short for integer. I want you to right now just think of integer as solid numbers like this for mathematical purposes. You can add, subtract, multiply, divide. The numbers can be as small as negative this big number right here and positive this big number. Anything bigger than that has to be placed somewhere else. And float is where you see the decimals. Whenever you see like the price of something, $29.99, for example. Whenever there's a decimal and then a bunch of numbers, that goes into float. I don't want you to overthink it, just take it like that. So int is a solid number like 35. This would be an int. But if I have 3.14, like the number of the pi, that will be called a float or be stored in a data type called float. Okay. Now there's another data type for date. Anytime we want to store date, we have to specify SQL that, hey, I'm storing date. So put a dash in between the month and the day and so forth. That's how SQL is going to know, okay, I need to put a dash in between this data. This is a different kind of data. Okay. All right. Any question about the basics of this understanding of data types that are out there? Let's take a look at how to create a table. You need to specify what data type before you build a table. And the way to build a table is you write create table, you give it the table name, and in parentheses, you list all the columns you want. Here's column 1, and you say what type of data that column is going to hold. If it's going to be a string, is it going to be a char, is it going to be a date, is it going to be integer, int, or float, meaning decimal. For now, let's just focus on that. Here's another column with a comma, another data type, another column with another data type. And go ahead, Chisti. Here's an example that we're going to do.
So before further proceeding, so I should clarify, should I be clarified about the integer and what the other one, that is string. So integer is the mathematical number and string is the non-mathematical number. Am I right?
Correct.
Okay.
Very good. And I will elaborate and go deeper into those a little bit later. I like to give less concept because I find whenever I give too much concept, I lose people. And I see that when I give examples, and then give them hands-on, and then bring them back with more concepts on it, that helps a little bit more. So you will see I will reiterate about string and integer and go into the differences a little bit later. If I get the chance now, if not, definitely in Java classes. So let's see. How are we going to create this table? Here's a question. It's asking you, create a table called persons. Okay, we want to give it the name called persons that contains 5 columns and gave you the column names, person ID, last name. Boy, I don't see 5 columns. Last name, address, city. Okay, maybe this is a typo. Should be like 4 columns. Or I'm not reading this correctly. So persons table, 4 columns, person's ID, last name, address, and city. So let's do that. And I think the SQL editor is going to allow us to write this table here. So we'll do this. So we're going to follow our syntax. First thing is command called create table, right? In this create table, now you're going to give it a name. However way you write the name, that's how it's going to show up. We're just going to call it exactly what the question is asking. Persons. 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 And then now you have this open bracket and then close bracket and semicolon to close that and leave it like this. Go inside this open bracket. And in here, you can start listing the column names and the data type. So first column name is person ID. Give it a space. And because it's ID, it's a number, your choice. If you don't need to do any kind of mathematics on it, you could just call it, a char, varchar, or string. Or if you wanted to call it an int, that's fine too. You can give it a number here. Then your next column, last name. By the way, we're not going to use the word string. String is going to be used in Java. So we're going to be using, instead of string, varchar. Varchar is more than one character. And you can put an open close parenthesis and say how many characters you need. You could say, I don't think last name is going to be more than 100 characters. Someone's going to say 100. 100 is a max character it's going to allow. And then you comma and move on to the next one. The next one is address. I say I don't want to put integer, I want to put character. So we'll say varchar, open close here, and then say address is bigger than last name. So let's just say 200. Comma, one more, city column we want. And let's call that also varchar. We don't need to do any dates or calculations. Leave it like that. And city name is 50 characters is fine. That ought to do it. And then you hit run SQL. What you get is, it's called you have made changes to the database. That means now, if you look down here, you got a table just got added to the database called Parsons. Any question on how to create a table?
The character type, the varchar, it can contain number and alphabet both, right?
It can. But the thing is, you cannot do any kind of mathematical operations on them.
Okay, because for the address, it will be number and alphabet mixed.
Correct. So the characters, you see, the characters, everything that you see on your keyboard, including the numbers. You can store it as a
table, please.
Which table?
The newly created table.
If I click
Awesome.
on this newly created table, it's not going to show me anything because it's empty right now, has 0 records.
So it will not even show the columns that we created.
It might show the columns. So if I click on it, let's see, select all from persons, or may not. No results, so it won't show anything unless you put some data in it. Let's go ahead and put some data in it, okay? So insert information into the table. This is how you're going to insert. Remember how we did the insert before? Insert record into the table. Who can tell me?
Insert into?
Correct. Insert into What? Table name.
Yep.
And
Then would it be the values or something like that?
values, correct?
Then it should be within the curly bracket according to the table that we wrote.
Correct.
According to the column, is it?
Correct, exactly, according to the columns. So we know we put in 4 columns in there. Yes? Our first one, we put in person's ID. So let's give it a 1. Second, we said last name. Let's say Jackson. Third, we said address 123 Road. And fourth, we said city, and we can say New York and run it. And it says 1 row affected. And if I go down here and look at this person's, I see this 1 record there. Now if I say select, so here's this query. If I say select all, so if I write select star from persons, delete this and run it, I see the table. With me so far?
Yes.
Let's add another column, another record. So how would I do that? Go ahead, tell me. Come on. Unmute yourself. This is your opportunity to talk. If you're not practicing,
Would it be add into or insert into? I'm
insert,
confused. I forgot.
Insert into. Insert into.
And then the new data. Insert into, then the table name.
Persons.
Okay.
Values.
Then values, the new according to the column that we made earlier.
Right. So I'm going to do 2. Last name Smith. Address 789 Street. And city Dallas. Run it. 1 row affected. Click on that. We got 1 Smith Road in Dallas. Okay. Now, what if you wanted to go in this table and you're like, I needed 1 more column and I forgot the first name column. You can go and change that. Okay. The way to change that is alter command. And altering the table will allow you to do that. So you invoke this command called alter table and give it the table name, persons. And then the word is add, because this keyword add lets the SQL know you're adding a special something to that structure of the table, not data, you're adding a structure. So at this point, you could say, I need to add first name column, and you have to say what data type. Well, we want it as varchar. And we want maybe 100 characters at the most. Finish it off with a semicolon, hit the run SQL, and it's going to say you have made changes to the database. And now, if I display this table, look what happened. I got this first name added, but there's no data. But that first name column got added. You are able to do that to any table structure with this command called alter table. Any questions there?
I'm not sure whether you'll display it on the on letter or not. If I want to write some data in the newly created column, how can we do that?
So we're gonna go back to our knowledge of how we're gonna add data here.
Mm-hmm.
Hey, Chisti, that's a
Is it like
awesome,
update?
yes, awesome question, Chisti. Let's make it a challenge for everybody, guys. How do we add value here? Let's say we added this column, but didn't add anything there. What do we do?
Update.
Is it update?
Can we do
Okay, we'll try it. Update what?
update the table name, then update space persons,
Mm-hmm.
set first name equals, say, Michael,
Okay.
where
Uh-huh.
first name equals null, or first name just equals quotation, the blank quotation.
You're almost there. You're almost there. There's a little technical difficulty here.
Where person ID equals.
No. Oh.
Where, yep.
Huh?
Person's ID equal Jackson.
No, one.
No.
Right.
Person ID cannot be equal to Jackson.
Oh, person ID equals 1.
Equals 1. Yeah, person ID equals 1. This logic works. Okay. Is this logic okay? Yes. You're saying set first name to Michael. So you want to set this first name to Michael, where person ID is equal to 1. Yeah, let's run it. You got one row affected. Go in there, and now we have Michael. Good job.
Teamwork.
Yeah, teamwork. That's it, guys. That's all I got for you. You now know how to create a table. You now know how to add value to the table. You know how to add an extra column to the table. You can also drop table, by the way, guys. You can say drop table. Persons. And that's gonna get rid of that table from here. So none of this is on the homework, by the way, just wanted to show you. But this is what a database administrator does. Rarely do they drop a table. They may add tables, new tables. They may modify the table a little bit, adding a new column or something. So rest of the time, they just sit in their office and wait for something to break, or if something breaks, or executive comes to them and say, hey, how about another table? So database admin in my office, this guy, he makes over $150,000 a year. I see him just walking around. Sometimes he comes to my booth and has like a 30 minutes to an hour of talk about what he did last weekend. This guy doesn't have much to do, but every company has at least one database administrator in case an executive comes to them and say, hey, I need a new table. Then this guy is going to go in there and he's going to create a new table with that structure in mind. He's going to be expert in this area that will give the executive an idea of, okay, you should have column this way, you should have data type this way, and that's how you should design it, and I'll design it for you, and then you can start adding data into it. So again, if you want to go in this road, you can study further and you can even land a job. I know a friend of mine, this guy, he just went online and he started studying himself. And then he just went out there and appeared for an interview and got a job because he was able to talk himself through the interview and get a job as a database admin. So it's not impossible. I mean, was this guy genius though? But yeah, I mean, he's like a super go-getter that he was able to just teach himself and then get the job. Not all of us are like that. Even myself, I think that it might be too long of a stretch for me uh, to take that risk. But you are in the safe zone here as a QA with automation experience and things that you're going to learn here. It's going to guarantee you that level of success, and you're going to get that confidence through this program. So you're in the right track. To sum up all the commands that you have learned so far in SQL, they can be categorized under a set sections. And this often comes in the interviews. And these sections are, they have names for them. You know, we've done this select. We started our query with select. We've done the insert. We've done the update. We've done delete. We've done create. I showed you drop. I showed you alter. I did not show you truncate. Really not needed. I did not show you grant and revoke. These are for allowing people permission. Grant is when the DB admin will give somebody access to certain deletion. If you don't have access, you can do this delete or this drop command all day long. It won't delete anything from the database because you don't even have access to. So that's when this grant command come in, and your database admin can grant you access as a read only or grant you access to be able to drop things. That's his choice. He has a list of things that he can do using this command. And at this point, I really don't know how these commands are used. I just know that these are these commands there that they do that. You only need to know that. If recruiter asks you, how would you provide permission to another user, you would say, I would use SQL grant command. If they ask you, how would you take away permission from a user, you would say, I would use the revoke command to take away. Okay. Similarly, there's a couple more. There's one called commit. Commit, you're going to see it in Java and Selenium. Commit is like you make commitment. Think of like commitment. You're in a relationship, you want to be committed to in your relationship. It's kind of like that. That means you have made up your mind and you are not going to change it. This is a fancy word for save. When you save the data, like you've done all the changes, now you're ready to save it. Commit is a stronger word than save. Save is like, yeah, I got saved it, and now I want to change it now. No, you don't change. When you commit, you have been committed, and you hopefully don't change that. You live with that for the rest of your life. Okay, so that's what that is. Now, if they ask you, how do you finalize data? How do you finalize the changes of the SQL database that you made? You would say, I would use the commit command to finalize the data. Okay. if they say, how would you change something that you have committed? You can still change it. If you made a commitment, you can still change it. The way to do that is called rollback. This rollback command is going to revert back to how it was one step before. Now you can also go 2 steps before or 3 steps before. You will see this kind of thing come up when we write our Java code for automation. You can roll back. Let's say you made a mistake, you saved your data, and you're like, okay, I want to go back 1 step because this thing that I saved is wrong and I want my previous code back. You can go back 1 step. Not only that, you can actually go back however many steps you want to go back without losing any work that you have done. As long as you, let's say, made a commit here, you saved it, you made a commit here, and then you made a commit here. Each of these commit is going to have a unique number. Let's say this is 1, 2, 3. This is 1, 2, 4. This is 1, 2, 5. You could say, my thing is not working here. I want to roll back to 1, 2, 5. Then it's going to take you to this part right here and delete everything else that you added later. You could go back to say, no, I want to go back to 1, 2, 4. Commit 1, 2, 4. It's going to take you to 1, 2, 4 and delete everything in 1, 2, 5 and everything else you committed later. With me so far? That's the whole point of this commit and rollback, and you have this function in SQL. There's another thing called save point. Save point is just a marker. You can put save point and go back to those particular save point and it will take you there. So if you hit the save point command and you give it a number, let's say, you can always go back to that specific number without committing it. And you can do that too. None of this really come into your interviews, but if they do, you have it. What they're going to do is they're going to ask you to write a select query. I guarantee you, if they ask you any SQL question, this is where you need to focus on. Now, if they are super hard on you, then they might ask you to insert, update, and this is it. Okay? So expect questions. Get yourself very good with this. And select meaning you need to know union, meaning you need to know join. They may ask you questions about these things. And they may or may not, very unlikely that they might give you here. They will never ask you to write a query of these or these or these, but they might ask you, what do these mean? What do these mean? Okay, and you may need to explain that a little bit. How do you create table? They might just say, how do you create a table in SQL? What command do you use? Your answer is as small as just one word. You might think it's a very complicated question, but the recruiter is only wanting to hear this word from you. Create. If you can't remember that, you got no points on that. Okay? Now, one other thing that they might try to refer into, what happened is these commands got grouped together under a certain category. All of these commands got grouped together under a certain category. And here are the category names. First one you have done is called data query language. So under the SQL, there is something called data query language. And that's select. All it does, it gives you data back. So in short, it's called DQL. So your recruiter might say, what are the commands under DQL? Or the recruiter might say, what's a DQL? You have to say the acronym that it is data query language. And these commands give you data back without making any changes to the data. And one of the commands that's in DQL is called select. All right, that's all there is to it, to this question. They could ask you what is data manipulation language, or DML. Manipulation means change. Query means search. Over here, you are changing the data. You are adding the data. You are manipulating the data. That's why it's called DML. In that case, you got this insert, update, delete. That was our yesterday's class that we did. The next thing is data definition language. All of this is categorized under definition. What does definition meaning? You're defining. Defining meaning you're creating. We just did this. When we created the table, we defined the table. We designed it. We said what we wanted in that table, how many columns, what column data type we're going to be using in those columns. That's why they use this word definition. In short, DDL. So remember that. DDL is data definition language. This is where you create table. You alter the table. You change the structure of the table. Nothing to do with data. Data insert goes here. Data adding, deleting goes here. This is table adding, deleting. Table structure adding, deleting. And just to get to display data is here. Next, you got this data control language. Notice they use control because you are using who has access, either grant them access or take away control from them, revoke. Revoke means take away or reject. Same word. Data control language, or DCL. And transaction control language, or TCL. Transaction meaning kind of like you go to a shop and you punch your credit card and you do a purchase. It's a transaction. This works kind of like that. You create a transaction of when you saved it, so it gives you a transaction number. When you rolled it back, it gives you a transaction number. When you put a save point, it also gives you a transaction number that you can refer back to. This is like a little spot, little point, a mark that you make. Either you save it, roll back, or save point for it. That's why it's called transaction control language, or TCL. I had an interviewer ask me, can you explain what TCL is? But he did kind of give me a hint first that he's gonna, he asked me, how good are you with database? I say, good enough to get my job done as a QA analyst. That was my answer. And then he said, what is TCL? Can you tell me a little bit about TCL? Luckily, I remember. The TCL is transaction language, control language. And these are commands, SQL commands, to either commit, roll back, or save point. That's it. I mean, he didn't ask any more follow-up questions because I am not a database admin who really works with these kinds of things. I just wanted to show him that I have the knowledge of. They don't expect me to write up a query with commit, rollback, or save point, because I would never do that. Only database admin would do that.
So,
That's all I got for you on this. Any question?
yeah, so the DCL, data control language, and transaction control language, both are subjected to the permission, is it?
No. Well, yes. Yes. You won't be able to do this without special permission. And you won't be able to, this is like the greatest permission level. Only the highest level of permission can do grant and revoke. And second highest would be to commit. Okay. Probably same level right here, data definition. You would never do this. Quality assurance will not be given permission to alter, truncate, or drop table. I did not show you an example of truncate, but truncate, what it does is, let's say you got this table right here, and you got all this data. Drop is going to totally delete the table. Truncate is just not going to delete the table, but delete all the records in the table. It's going to become empty. That's what truncate does. Again, we are not going to be given permissions. In fact, I've never done a query here either. The only query that I worked with is select right here. But you have been given examples and you've done hands-on. You're going to be doing this on homework hands-on. So at this point, after the homework is done, technically, you know more than what the market is going to expect of you. So you should give yourself a pat on the back. You should give yourself a whole boost of confidence that you are in good hands. I do need you to memorize this PowerPoint slide right here. Either write it down on a piece of paper like a notepad, note card. This is very difficult to remember. There's a lot of commands in here. You should have this in front of you before you take any interview whatsoever. If you're not doing that, you're setting up yourself for failure. And whose fault is going to be that?
So what I did, I went to your web page.
Mm-hmm.
I downloaded all the classes in PDF format and saved in a file so that I can get all the PowerPoints whenever I need it. And
That's great.
probably I'll get the printout of all those to make a book or binder so
That's
that
great.
I can have.
That's great. That works too. But understand that when it's interview, you don't have time to go flip through the pages. Okay? You don't have time to do that. If you do that, it just shows it's just going to turn out weird. You got a few seconds before you answer the question. I want you to take a few seconds. Don't answer the question immediately. That just says you're not mature. They ask you a question, take a deep breath, take a couple of seconds. Let them see that you are formulating the answer in your mind. That just shows that you are very mature, you're deep thinking, and you don't rush through things. It shows a lot about personality that they might prefer. So within that few seconds, you're not going to have enough time to flip through those pages to get to the slide. The only way you can do that is if you create a flashcard and stick it on a wall. So stick this on a wall and keep looking at it every day from now on. Put it in your pocket. Go places. Test yourself. See if you remember these acronyms. See if you remember these. See if you remember which all four. Memorize all four. The DDL is create, drop, alter, truncate. Memorize it. And then stick it on the wall. Before the interview, you look at that wall. You're facing the wall. Interviewer doesn't know. It's going to be over the phone. Interviewer doesn't know what you're looking at. You're standing in front of the wall with the phone on your head, and you're looking at that, and you're like, "Oh, you got a SQL question? I know that. That's where my sticky note is." You're looking at your sticky note, and you're formulating an answer right in front of the recruiter. The recruiter doesn't know you're looking at this, and this is an open book for you. Yeah.
Oh, so that's great. If we can use the open book or something like that, maybe the cell phone to check the flashcard, is it okay in front of the interviewer?
Yes, but trust me, no matter what technology is not going to work here. unless you have a 100 inches TV screen with all the small information written in one screen. You don't have time to flip screens. Okay. You won't, because their question is going to be all over the place. They're going to go from Sprint to Java. They're going to jump around Selenium. They're going to come back to SQL. How are you going to flip through? Nothing is going to work. I promise you. The only thing that you got that's going to work is write this down. Either print this piece of paper. Just print this slide if you want to print it. If you don't want to print it, you want to write it down, even better. Because when you write it down, your hand-brain coordination works and your memory works better. And the way you write it down might be different than how I have it here presented. You design it the way your brain sees it fit. That makes it even stronger for you to remember. Not all visuals work the same or hit the same people the same way. Everybody learn differently. So you write it down the way you can remember better. Now take that flashcard. Flashcard is nothing but just a piece of paper that's like looks like a picture, 3x5 picture, a photo, and then you stick that on the wall, and you keep sticking these things. So many things I've done with you so far. How many of you have actually done that? You should be working on that now, because you're going to be in market in about a 2 to 3 months. Where things are coming in fast. We're gonna do Java next week, so you're there now. You're hands on. You're gonna be typing. You're gonna be writing code. So, and then the moment the class is over, I hope you're ready for the market. I want to see you have those flashcards ready, or it's gonna be run around. Because the moment we upload your resume, you're gonna get calls like crazy. You're not gonna have time for preparation and all that. You're gonna start getting interviews. So start working now. Get these flashcards ready. Put it on the wall. Keep looking at it. Keep repeating yourself. Practice with me when I ask you these questions. It does. You can't just cram everything before the test and then expect to have a good result. It's not going to work like that. Practice from early on and hard code it in your brain with this so you can remember longer. That's all I got for you guys. This is probably the most important slide in here. There is a formula that I added here. You're welcome to play around with this. I don't want to go into it, but if you need a easy way to remember all of these, I have created this for you, where you can start with select, then column name, then from, then table, then where, and then the column name. With the conditional statement, you can put any one of these combinations, and then the value, and then the group by comes last, if you wanted to remember. If you wanted to add another where condition, you can do it with the having, and then having has to have to do with this aggregation with the column name, and then always finish it up with the order by. So if you have to do an order, you order by, and then do that. If you want to limit how many data you want to see, that comes at the very last, which you say limit, and then the number of how many you want to limit it to. Again, this is nowhere in the internet or anything. I just kind of try to come up with a formula of my own and a sequence. You're welcome to follow this sequence. You can write it down. You can even print this, put it on a flashcard for yourself in case they ask you a question and you forgot how I'm going to create one. Then this will remind you, oh, select, and then I need the column name. What are the column name is the recruiter asking for? And then from and the table name. What's the table name they're asking for? I know that this helped me when I went into the interview. I didn't want to have so many examples in front of me. I just wanted one structure. And with this slide that I created at the time, really helped me. That was for your DQL, meaning you are searching the data. Chances are your question is going to stay here. You won't get anything more than that. But if somebody wants to be super hard on you, then they could give you questions with DML or data manipulation language, which is insert into, update, or delete from. Delete from I didn't show you. But same way it's done. Any one of these, you have to write the table name right after these commands. So the immediate, like insert into, you saw we wrote the table name. Update, we wrote the table name. Delete from, you have to write the table name. And then you have to provide values. Okay. Which value? If you wanted to insert into, you have to say values. If you say update, then you have to say set. And then you have those data type like that. And then you have your where clause after that, just as usual. And then your condition. And if you say delete from table, your next statement comes to where, and then you finish up with the condition like that. But again, I don't think you get any question anybody will ask you how to give me how to insert a data into a table. They won't. You won't be doing that. But if you want to learn and you want to keep this slide next to you, practice and get better, but really advance at this, feel free to do that. Here's a homework, 10 questions. It's in Google Classroom, has been assigned. It's going to be due next Sunday. Most of your work has been graded and submitted. If you have not submitted your work yet, go ahead and still submit. Shoot me a text that you have done it, because I've looked at everything and I've graded everything so far. So if anything new coming in, I may not know if you submitted it. So let me know and I can do that. That's all I got for you. Any questions before we end the class today?
Yeah, can you